Welcome to a lesson with Dr. Powell. Let's consider the idea of what it means for an action on vectors to fix or leave invariant a subspace. So here's a simple example. Rescaling is an action. Like, what if you were to double two basis vectors that make up a plane um, as a subspace of R3? Well, if you were to do that, it wouldn't change the plane at all. It would still be the same plane, and just the coordinates that you would read off in terms of these basis vectors would be different. You would take the coordinates, the new coordinates that we would have after doubling the basis vectors. The scalar coefficients would be 1/2 of what they were previously to get to the same points. Okay, so what does that mean? Rescaling the vectors in the subspace, leave it alone. It's still the same subspace. I mean, you've moved the vectors around in it a little bit, but however, you haven't moved vectors out of the subspace. It's closed. It's like a closed box when we're multiplying by scalars. In fact, that is one of the properties of being a subspace, is you need that the scalar action is closed on it. You can't move outside of it by multiplying by real numbers. Now, this brings up an interesting point, because we've been extending our scalars by thinking of a matrix as being like a scalar. And if we do that and intermixing its action with other scalars through addition and multiplication and itself and so forth, we actually get the set of polynomials, Rx here, set of polynomials in X with real coefficients. So these are our new scalars. Now, let's consider what happens when these new scalars act on subspaces. They're not going to fix all the same ones than just R did, but they still will sometimes and often fix certain subspaces. Here's an example. What if we have this matrix right here? It's a simple example where all this matrix does is switch X and Y, or the Y and Z, sorry, the Y and Z coordinates. Okay, so if you're switching the Y and Z coordinates, that's like reflecting about the line Y equals Z. Okay, and notice that actually keeps this YZ plane the same. It doesn't move vectors out of it, it keeps vectors in it. So what we're going to be doing in the next set of videos is we're going to be talking about actions that keep certain subspaces invariant. In particular, we're going to be looking at for a given matrix, we're going to be discussing and determining what the invariant subspaces are associated with that matrix. What does it actually fix? Thanks for watching.